Welcome to Maven's Talk series. This session is about release engineering and management. Programmed by Digitaranti, India's first IT finishing school.
Different aspects of release management and what has really changed for an SRE behind the scenes. So I'm not going to talk about an SRE as a word multiple times. I'm going to see the perspective of release management, what has changed, and how we can sort of build it all together. So the journey, about the 45 minutes journey with me today, I'll cover the basics of what release management is. Again, this is not a theoretical topic, so we can look at various examples and how this works, but it does touch upon various evolution. I do understand that your organization is doing a massive transformation to agile, cloud, and all of those, which means understanding, knowing where to start from is very important. And that's where the delivery channels come in. I look at waterfall and an agile model or a DevOps channel are delivery channels to deliver some of these transformations. Then we look at release strategies, which is what sort of the various components, how release strategies is evolving with cloud, with the demands in the market. And obviously to end with, let's look at modernization and what the future holds, right? In terms of release management. So one of the biggest things that you have looked, I don't know if you've seen it, but there is one organization which does about 23,000 deployments a day. This was about 4 years ago. Quite likely this has increased even further. There is no data available beyond this. This data is from Amazon. Amazon is a retailing organization, which means the competition is very high. They need to launch new, let's take examples of coupons, discounts, payment systems, new kind of payment system keeps coming in, integrations with different APIs from the banking platform. All of those need to be done for a product like Amazon, which now encompasses every day-to-day activity of a human being, right? I mean, the moment you wake up with an Alexa, which wakes you up probably with an alarm or with a music, then you do shopping, then you're looking at their Amazon Prime audio or video services, anything or your application or any website that you hit quite likely is hosted on AWS as well. So a combination of all of this, they do 23,000 deployments a day. So what does a release manager have to do? Do you think there will be, if there was a release manager sitting there approving 23,000 releases or change requests, is this humanly possible? Maybe no. And again, that's one side of the story. If you look at the other side of the story, if let's say Boeing as an aeroplane says, okay, just taking the simple prior example to set the context, Alexa gets updated while you're listening to music, right? Maybe your phone gets updated while you're listening to music. Your Amazon website is getting updated while you're browsing the website, but you don't see disruption. But it's still okay, even if you see a little bit of a disruption. But let's say now in the same context, Boeing or GE Healthcare says while your heart is being monitored or you're in the air, flying from one destination to the other, if Boeing comes and makes a claim saying we do 23,000 deployments when the flight is in the air, I seriously doubt any of us will be confident enough to get onto that plane, irrespective of how much confidence they give us, saying it's foolproof, you can roll back quickly, you can do great stuff, etc. There are certain aspects of business where you cannot get into these areas. So maybe a financial system, maybe a retail banking, maybe investment banking, etc., could lie somewhere between these two extreme paradigms of 23,000 deployments a day to only a deployment when the plane is in the hangar, and only then you're willing to upgrade it, and not really when the plane is at 30,000 feet, right? So that's the evolution of a release manager. And let's say if there is a release manager looking for a job opportunity and says, oh, I'll go to Amazon because they do 23,000 deployments a day, versus somebody who takes the job at Boeing, their requirements, their expectations is very, very different. The number of deployments doesn't really demand mean the complexity of the other end not so high. So that's the complexity, or that's the range with which a release manager operates these days. So what's a release? Let's go back to a little bit of a basic in terms of what's a release. Any change to the system, and an SRE particularly is is um, is bothered about a change, right? I mean, that's the lightest I can put it. An SRE is looking at making the system stable, ensuring nothing really bad happens so that the customer has a great experience. So SRE is a shield between the developer and the customer, right? And when I say shield, it's not just a shield. I mean, you could also say a QA is a shield, but it's also about representing. SRE represents some aspects of saying if the developer has a problem, if the consumer has a problem, how can I consume it, and how can I relate it to a business requirement and ensure things don't fail. So in a change evolution, you see what kind of changes can happen. An application can change, which is the software change. An infra can change, which could be scaling up and down. There are more consumers coming onto your website, so you obviously need to make changes to accommodate. There could be a config change in the legacy world. You could say at the end of a day, you switch a parameter which stops all the banking transactions for the retail and maybe does batch processing at behind the scenes. And then there is data and documentation. Let's say every 15 days, an SRE goes and cleans up the data which is not required. Maybe updates the documentation for the user, updates the documentation for internal consumption, right? So these are various kinds of, and there could be many more. So these are changes which the SRE is protecting, right? And why it's protecting a developers. I mean, there are let's say take three roles. A product guy is more keen on bringing in new functionality into the product. A developer is keen on pushing whatever the person has done into production, saying, oh, I want to see what I have done in production. And the SRE is worried about keeping the stability on the system. And these three are contradicting roles with different objectives for each of them, right? So they have to combine together to ensure a release happens well. And that's what is release management, right? So when you're looking at release management, it is about end-to-end process. A new request for a change comes. You plan when this function has to go into production, into staging, into different environments, and not just planning at the end. You could be planning at the beginning of the cycle. If you're doing agile, you're obviously planning on a regular basis. Then the person has to look at the software build. And when you're looking at planning and designing, you also need to ensure, let's say, take an example of Amazon again. You want to include a feature which changes the banner language, right? And this feature potentially needs to go to Amazon US, Amazon India, Amazon Singapore, Amazon, right? And if that needs to be done, the release management has to pitch in, work with the portfolio management team and say this functionality needs to go to 4 different countries. How do we implement it across different setups, right? So that's where is the objective of release planning. And then obviously you review, you put change management processes, you test, you validate whether all these releases are good. You deploy. Once you deploy, the SRE comes in. Again, I'm not saying the SRE is only in the support aspect, but in the agile processes involved in all the processes before. And then issue reporting and collection, that's also a function of. So if you see potentially a 6, 7, 8 is where the SRE pitches in a legacy ecosystem. In a modern ecosystem of a DevOps oriented and an agile oriented team, the SRE is involved 1 to 8 steps, right? So this is the context setting of a release management. But what are the delivery channels? So delivery channels are the way or the processes in which the software development lifecycle happens, right? The initial one was obviously the waterfall model, right? If you're looking at the waterfall model, the requirements come in. This was the first, most of us have done this. This is how many organizations run even today. Even people who say agile is being implemented very heavily, you are sort of doing a pseudo waterfall agile model where there are certain steps which happen one after the other, maybe the requirements of the customers or in a sequential manner. Then the development process, the QA process potentially is another agile methodology. And then once it passes on to the deployment, again sort of becomes a waterfallish model, right? So organizations are shifting between each other. It would be a surprise if somebody says we deploy agile 100%. Maybe there are few, maybe startups, but again, somewhere in between. I mean, there is nothing wrong, right or wrong in this process. One is sequential, one is iterative. That's the delivery channel. And why I say it's a delivery channel is because the software gets delivered through this process. And agile is developed in software. I mean, it's the SDLC process. So let's get into a little bit of a change in terms of what doesn't change. Irrespective of whether you use DevOps, you use Agile, and when I say DevOps, DevOps culture, which is sort of a next step of Agile, or if you use safe methodologies, or if you use the legacy waterfall model, things that don't change in the ecosystem are business priorities, infrastructure requirements, and how customers use it, right? I mean, this is the other end of the spectrum. So priorities, obviously, when they want, why they want, how they want, really does not change. I mean, irrespective of what methodology you use. I mean, it's like a customer wants wants a toothpaste. It doesn't matter what Colgate or Unilever behind the scenes is using as a mechanism internally, but they ensure that it is delivered to the customer at the time they want, the way they want, and at the timelines that they want, right? So that's the priorities don't change irrespective of which methodology. Infrastructure needs, obviously, the way it's done, let's say a cloud, a hybrid, or a complete data center methodology, or even a public cloud structure. This could be changing, but again, the needs per se, an application needs a particular infrastructure. The more the demand, the more the infrastructure. The scaling needs to be taken care, which is also an SRE job. And all these, and any kind of customization that needs to be done at an infrastructure level needs to be taken care by the SRE, right? And how the customer uses it. I mean, you and I are customer for majority of the products. Even for the companies that we work in, we are customers to it in various different ways and forms, right? The way the customer could use it on a web, mobile, in-house application where it's like a B2B application, API interactions, all of those. If you see, this is the completely other view, other phase of the software development lifecycle. How all of these are used is doesn't change for an SRE, doesn't change for a business, right? You could deploy a different mechanism or a machinery to develop agile, safe, etc. These aspects don't change. So how do we move up the value chain, right? And you could say we are doing waterfall. Waterfall sort of lands into a plan. I mean, all of this put together in a very sequential fashion is sort of a waterfallish model. But what happens in an agile development is your plan, code, build cycle is sort of automated in a particular sequence, which is what your agile development. One step above would be your continuous integration, where you integrate, test, validate, saying all of this is ready. Then is continuous delivery. You say you build, test, everything is ready, and I'm ready to push to production, right? And then DevOps is also even one level higher, is where you operate as well in a continuous manner, which is you put in metrics, you put in auto healing, you put in automation of an infrastructure, automation of scaling, automation of cleanup activities, etc., into the plan, build, code, test cycle. So an operator steps back, works along with the development team, does the plan, code, build cycle, even on the infrastructure, network, firewall, all of those aspects, and ensure the whole product is shipped as one go, which includes all of these parameters together. Sorry. So while we progress on this, one key aspect to remember, which is for an SRE, a DevOps guy, or anyone in the SDLC, is the difference between continuous delivery and continuous deployment, right? The one that we saw earlier is the same thing in a slightly different fashion. You test, you do various different kinds of tests, you deliver it to staging, you again do some kind of application test, then you deliver to production, and once you deliver to production, you have, let's say, user acceptance test again, or stability test, or validation in some way or form. So, and you could have 10 different environments, the final one being production. So the difference between a delivery and a deployment is continuous delivery delivers everything one step before production in a fully automated manner. And things that go to production could be a change request in Snow, ITIL, Remedy, or whatever tool that you use. Where when I say Snow ServiceNow, you click a button and say, okay, now it's ready for production, and somebody accepts. Right? So that's the step of moving to production being the manual process, which is what is highlighted in pink in the manual process. A continuous deployment model is where everything up, including production, goes in a completely automated fashion. So as soon as a developer checks in code, maybe somebody is doing a pull request. As soon as that pull request is approved, it gets built, it gets tested, it gets validated, it gets pushed to, it gets deployed to production or various different environments, then to production, and then post-production validations are also done, and customers are ready to use, right? Maybe there are parameters which are automatically set in place saying, which we will look at in terms of the deployment models or deployment strategies, how this could be implemented. But if you notice, this end-to-end process is completely automated in a continuous deployment strategy, right? So this is the difference between continuous delivery and deployment. So in a nutshell, in what we talked about so far, so the waterfall was design, code, test, and deployment in a fairly sequential fashion, and you would get to a version V1. I've worked in various banking institutions in the past, and I could tell each of these versions would happen. Sometimes the next release was 2 years away, right? We've seen situations where you deploy something to production once every 2 years, 1 year, 6 months, etc. Used to work, but the demand in 2 years, a new fintech company will come and probably eliminate our business, right? So the companies need to be agile. So when you get to the agile methodology, you are doing iterations of the same design, code, test, and deploy. When I say V1, V2, these are continuous delivery, and then you're deploying to production at one go when you are arrow mark. So you do, let's say, 4 iterations of design, code, test, and deploy, but deploy to production, if you see the green, the deploy happens at the end. But in a DevOps cycle, you're sort of compressing even that, because you're implementing a lot of automation aspects. You're doing a design, code, test, and deploy at a much faster sequence. And this is where you can achieve that initial 23,000 deployments a day, or maybe more. I mean, I work for Amadeus. There are systems which deploy even more than 23,000 deployments a day. But is it needed, not needed, is something that we need to look and evaluate for that system. So let's take the traditional versus modern system, which is sort of an extension to the prior slide itself. Most of us are aware of how the process used to work, right? So you would release a major release, which is V1, V2, V3, V4. Then you would have a minor release, which would probably happen once every month, once every 2 months. Then if there is a customer problem, you have to do a hot fix, you have to patch, you have to do security patches. You would create, let's say, a patch release. So you would do a 1.0.0 kind of a thing, right? And then you would have labels in a release process. So this, again, this is a representation of versioning, which is not what I want to get into. But if you see, how a release used to happen. Major could be once a year, minor could be once a month, patch could be once every 2-3 days whenever there is a hot fix, and labels are like intermittent releases that you do for your stuff. Right? In an agile methodology, if you see, and this is where you are seeing how fast a process happens. This is a real-time data from one of the organizations. Not that I've worked in the past, but the if the green line represents uh, a slow and steady DevOps process. So the number of releases, number of deployments that you do, number of change or value that you deliver, right? And the red is more infrequent releases. So if you see red, every 90 days you're doing a release. So there is an incremental uptime in terms of the value delivered. And for 90 days, nothing really happens. Then again, you go to uh, go make a release. So you add a big chunk of functionality, then again 90 days, then okay, you have done almost a year, now you have a much bigger release, you push a much bigger release, and that's how you keep adding value over a period of time. In orange is sort of a monthly release. You do monthly release, but every month you're incrementally adding value, you're reaching a particular point. And in the green, you're adding value every single day, which is your continuous delivery, continuous deployment, CI/CD models, which is obviously over a period of time delivers more value to the customer than any other methodology, right? And the SRE obviously isn't the end of the life cycle. So if you say from 0 to 90, the SRE is, for the lack of words, not really adding value. He is looking at stability, maybe doing small tweaks, nothing fancy. And every 90 days, the SRE is working like 2-3 days non-stop, 24/7, ensuring things don't fail. And if things fail, they revert it, and etc. Right? But on a green line, the SRE is as busy adding value, not busy restarting servers, busy adding value to the whole product on a daily basis because they're working on to automate, helping the whole process, improving monitoring, improving observability, etc. in the whole process. So what are the key metrics that you need to manage in the whole process? SRE is obviously looking at availability. The four key metrics that you're looking at managing when you are doing good DevOps processes is lead time. Lead time is don't look at it from an SRE perspective. Lead time is customer makes a request and the time from there to the time it actually goes into production, right? So let's say a customer says, I want the banner to look, I should have a left button and a right button in the banner, right? I mean, a small functionality change. In the typical model, you say, oh, great functionality, my next release is 3 months away, I will implement it for you. But in a DevOps cycle, you say, okay, to make this change, I need to see, then I make this change, will my customer retention rate reduces? So I put that SRE team will come up with a metric, put a dashboard. The developer team along with that will say, okay, I take this requirement, make a UI change, I have a production release tomorrow, I have a microservice. So if I make this change, only this product is going to get affected. And then I release to production by evening. The customer comes in the morning, I've done all these changes, I am done pushing it into production by the evening. So the lead time in the first case was 90 days. The lead time in this case is 1 day. And if you think of it, I have done a release today, but I have done all the planning. I'm ready to go to production on 80th day in the legacy lifecycle. And the customer says, I have a new requirement. The person would say, oh, my release is already planned, it's ready, I can't do anything, it will go to the next release. So typically it's not 90 days, it could be anywhere between 90 to 180 days for a change to happen in the old time, and this lead time is a good measure to manage. And on the software development side, change fail ratio. So every time you make a change, how does it fail? Are you monitoring it? How can you quickly recover? How can you quickly fix the problem? But the change fail ratio is monitored on the deployment side of things. And deployment frequency obviously is the measure of the continuous delivery side, which is combination of lead time and change failure ratio, because the more times the change is failing, you're increasing the deployment, or maybe the other way around, because you're deploying so frequently, you know how things could go bad, and you fix it much earlier in the cycle, even before a customer notices it. So the job of all of these, and time to restore is obviously a combination between software development and service operation, is if the change happens, how quickly can you restore? And faster time to restore is also the function of a deployment frequency, how automated your functions are. So I would suggest you look at the state of DevOps report. It is a good annual report which comes up. This is a slightly dated report. Anyone who is looking into SRE, DevOps, automation, and any kind of and in those roles, a state of DevOps report is a must read, which is an annual report. So I won't get into the details. It's a data heavy slide. What this means is the maturity level in terms of your CI/CD, right? On the x-axis, you have the foundation where you are. Let's say I have a deployment server, right? That's good enough to say I'm at foundation of continuous delivery 3. And at the same extreme, if you are an expert, deployments on endless scalable platforms. So which means if I have a production ready code, it can automatically spin off an environment. It could deploy, it could auto scale down. All of this could happen on the expert level. So this is a good way to measure on different parameters of deployment, testing, integration, planning, artificial intelligence, etc. Not getting into the details of this at all. So a different perspective on the same thing. How can you make it? How can you gamify this whole process of the maturity model, right? So in the same process, let's say you could say infrastructure provisioning, delivery, maintenance. It could be an organization level. It could be at a team level. You could go do an analysis to say, okay, do you have multiple servers, or are you deploying into a single server? Are you deploying into a VM? And this blue line indicates where the current team or an organization is. And you could say in a cloud native model or in a future model, you want to be at this goal, and you could say this is the gap that you need to fix for your organization, for your team, to get to the next level. So this is a good process to have. You could have a dashboard, you could have real-time analysis which could be happening. You could gamify saying team 1 is here, team 2 is here, and you could start comparing and help push the teams to the next level. So this covers a lot of aspects that we talked about in terms of setting up the context of what SRE evolution is. Let's look at, there are two more large sections. One is the release strategies and one is the future. So let me rush through the release strategies so that we can touch upon the concept of what is in the future a little more. So release strategies, obviously, when you're doing an SRE, you have a version 1 and you want to go to a version 2. So this is the typical standard release process. You have a version 1, you deploy a version 2. If it is successful, it's all green. If it's a failure, it's all red, and you have to either roll back to the version 1 or figure out what to do. In a rolling release, obviously, which is a little more complex, you have multiple instances of your application. You deploy your application on one node. You see, is it okay? If it's okay, you go to the second node. If it's okay, you do to the third node. And so far, you keep rolling until all the nodes have gone into the newer version. So you move from version 1 to a version 2. Similarly, on a blue-green release, you have a staging release. I mean, you have two live environments in some ways. You stage all of it in one environment. You have something running on an older version which is live, which customers are using. You deploy all the requirements or all the application onto a new version on a new platform. Then you switch it, right? So you have you redirect traffic from live to staging, make staging live and live as staging. So you switch, and now your other environment becomes staging, and the live environment becomes the erstwhile staging. So this is a good deployment model where you can easily roll back to an old release without doing much of change. Again, this is canary release, which is very well adopted in startups and evolving organization. You have a before system of version 1.1. You have a live phase where one set or one group of nodes is deployed with a new release. You redirect traffic to you redirect some of the people onto this, monitor it, saying if this is working well. Then you deploy to the next set of servers, and then obviously the last one you have to complete all the nodes of the new ecosystem. AB is quite interesting. You have multiple releases on multiple different nodes. You have 1.2 sitting on one node, 1.3 sitting on another node, 1.2 sitting on one node, and then you redirect traffic to equally to all these three areas and see which is performing better than the other. And then you say, okay, 1.3 is working better than the others, so start rolling out more of 1.3 to everyone else. So this is a good typical strategy used in the retail e-commerce domain. So these were typical, sorry, I jumped. So these were various deployment strategies that you can adopt and implement it in your organization. And SRE is really important in this function because SRE comes with these strategies. Earlier, the SRE would say, okay, this is how do I ensure stability in the ecosystem? Now the stability in the ecosystem needs to be monitored at different parameters. If you saw let's say in the staging thing, it's very easy. It's a switch of a button which the SRE manages. If you're looking at this, you're monitoring, you deploy on one set of servers, manage, verify, move on to the second set of servers. And obviously, this is the more complex where there are dashboards and observability platforms that you have put in place to say which one is doing well, or you're pushing different amounts of traffic into different set of nodes and seeing how it performs. In some ways and forms, your integration test, your acceptance test is happening directly on production and maybe not on a pre ecosystem which is driving some of these. So obviously, the container model, things go very, very different. This is very modern in a push versus a pull model. You have always seen deployments which is push based. What is push based deployment is you do all your build, release, and push it into you have an artifact which you store in, let's say, NAS. You could store in JFrog Artifactory, you could store it in Nexus, you could store it in an S3 bucket. And once it's there, then you say, okay, there are 100 different servers. I will click a button or I will have an automation script which will go push into various different servers by my command, right? In a Kubernetes model, in a container model, it's very different. You say, as soon as a pull request is ready, you say this product or this artifact is ready to be pulled, and the application decides saying, okay, I now have low traffic into my node. I will pull the artifact and redeploy myself directly from any repository holding, right? I mean, as I said, NAS, JFrog, Artifactory, anything, right? So this is a pull versus a push model. We have got used to the push model since ages. Pull model is something which is coming very, very rapidly with the container ecosystem. So what does the future hold for us? So there are various things that are evolving in the SRE ecosystem and in the release management ecosystem. You have chat ops, functions over microservices, infrastructure as code and scaling, chaos engineering, feature flags, and hyper automation. Right? Let's touch upon all of this in a minute, and then we will have about 10 minutes for questions. So if you look at chat ops, all the SRE is playing the role of a manual trigger. A developer says, okay, the code is ready to be pushed. SRE takes that request, does the code release aspects and tests, validates, and pushes back the message to the developer saying everything's okay and all of that is good, right? But what if there is a persistent chat service, right? The human, the manual effort and the human is replaced, right? which is a bit of the hyper automation at the end. You automate every single process, a continuous delivery tool. You could say on the chat system, you could say commit this from X place, and it'll get committed. You will say approve pull request number, and it will automatically find where this pull request is, approve that in the system, and all that you're doing is typing all of this into your Slack channel or a Teams channel, which could be doubly secured with two-factor authentication, etc. And then you could say, okay, deploy to node A, deploy to node B, deploy to node C, and as soon as deploy of node A happens, you could get a feedback onto the same channel which everybody is on. Node A deployed, 20% of traffic rerouted, 100% uptime, no problem. Do you want to push it into node 2? Click yes, it deploys again, and go through together. Vijay asked this question, can you pause? This is an intermittent stage where you want to control, but it's 100% automated. You have automated the whole SRE process, but you're driving through chat. This could be driven by the SRE himself or herself, or could be driven by the developer, right? And all this is through the chat service, and many organizations have already gone into this model. This gives you high transparency. There is nothing called an SRE which is sitting somewhere, and getting information from an SRE is difficult, and it's completely conversation driven. You could have artificial intelligence, machine learning built into it, where if you make a mistake, it's going to come and make a suggestion. Or if you deploy to node 3 first before node 1, maybe the chances of failure is high. So let's start with node 1. Are you okay with node 1 instead of node 3? Or do you want to start node 3, right? So these are things that you can do with ChatOps. Functions, which is basically serverless kind of an application. The SRE, a lot of servers are used for batch processing, for very small tasks. For authentication, you have a VM. For let's say approving something, you have a VM running because you have a service running. But maybe you have a stateless server where you're using Amazon Lambda or any kind of Azure functions, which is on the cloud. You raise a request. As soon as that gets triggered, you say it's all okay. It passes back. The server does not exist, and it's completely scalable. You don't have to manage anything, and the SRE job completely reduces. You could call it a nano service, very easy to manage, auto scales, highly effective systems, which is what is very largely being used in micro activities. Infrastructure as code and scaling. SRE used to do a lot of maybe the infra automation was purely with an SRE or infrastructure automation person, and the application was completely with an application automation function. But we are seeing a convergence with DevOps, convergence with an SRE, new age SRE, where you're writing templates, scripts, policies, and you have obviously idempotent tools, which is like Ansible, Terraform, which is deploying your infrastructure, keeping it ready, and an application which, as soon as you deploy, it will first trigger all the Ansible scripts to prepare your infrastructure, and then deploys your code, right? So this is where your configurations, your infra is also going into a 100% automation methodology, which doesn't need an independent SRE to be triggering it off. Which means release management now happens not just for application, but happens for chaos engineering. Monkey business is good business, is the thing pioneered by Netflix, is an infrastructure. Earlier, the job of an SRE was to ensure stability, and ensuring stability earlier days was to ensure nothing really changes. But the new age mechanism is you have chaos engineering tools like Chaos Monkey, which automatically, let's say, shuts down a VM. It automatically changes some firewall parameters. It automatically disrupts a network. It automatically pushes random amount of network traffic onto your network, and it monitors whether your system can hold good. You could be doing this at 2 a.m. in the night, where if things fail, you know this is a potential failure point, and identifying. This is more like your treadmill test for your ensuring your heart is working well. You validate things before, ensuring things don't fail for the future. Feature flags dramatically being used. The job of a SRE earlier was to switch your traffic between one server to the other. It could be done with various feature flag tools. It could be done with ServiceNow. It could be done with other feature flag tools, or you could build your own feature flag ecosystem where you could say just like a switch, you could redirect traffic to different customers, different users, different location. It enables hyper localization, hyper customization. It is one code driven by flags, right? We can take this in questions if you have any in terms of understanding this. And SRE job is transforming into a lot of feature toggling, which this is the other term of feature. And last but not the least is hyper automation. If you do any activity once, ensure it's never done again, automate it. It could be business process automation. One of the jobs that Vijay asked is like there is a process, can we automate the process? You could automate business rules. You could automate the workflow. You could automate conversations. As I said, chatbots, smart speakers. I mean, in one of the stand-ups that we used to do in my prior organization, we would say at the end of the stand-up, we used to have an Echo, Amazon Echo at each of our desks. We could say, okay, application ready, Echo, please deploy code. And at end of the sprint, the code would get deployed. It would not get to deploy to production, but we would push all the way up to staging with voice commands, right? So that's the bit of hyper automation, and ensure all of this is inbuilt learn in the release management process. So just take a look at the ecosystem. I'll summarize all the points that I mentioned. Any kind of an adoption follows this adoption curve. You can sort of look at the curve. There will always be innovators which take a lot of time. Early adopters have a slight big adoption trend. Early majority obviously is when things become more famous, people adopt it, and late majority is the laggards. We've seen this in some of the airline domain, banking domain, where things go slow. But if you see all the technologies that are being used at different phases, this is sort of a newish report. General DevOps is being adopted, CI best practices adopted. But if you see chat ops, data ops, chaos engineering that I mentioned, is slightly on the early adopters or the innovators. This chart is to be read from right to left and not from left to right. And on the innovator side, we are seeing people adopt FinOps, data mesh, etc., cross cloud, hyper cloud, etc., being used largely in the innovator segment of the ecosystem.